Welcome to qnawire.
Okay, so we've got cyclohexane, and we need to know, would it be least soluble into pentanol, diethyl ether, methanol, or heptane? Okay, well, what's the basis by which we're determining how soluble cyclohexane will be? Polarity, right? Cyclohexane is very nonpolar. Very nonpolar, right? So basically, we're just going to look at our various solvents and decide which one is the most polar. The most polar one we have will be the cyclohexane will be the least soluble in. Right off the bat, we can rule out heptane, right? Because heptane is just, there's no heteroatoms. It's all carbon, and we know CH bonds and CC bonds are very nonpolar, so this is just a nonpolar solvent. The next one that we can rule out is diethyl ether. Why do we rule out diethyl ether? Well, it's basically because the other ones have OHs. They have essentially a bunch of hydrogen bonding going on. Oxygen-hydrogen bonds are very strongly polar. So are, to some extent, oxygen-carbon, but not nearly to the extent that oxygen-hydrogen bonds are. So in terms of polarity, our alcohols are going to be far more polar than our ether. Okay, so now we've got to decide between pentanol and methanol, which one is more polar, which one is less polar. And it turns out that methanol is more polar. The reason for it is that they both contain the same delta positive, delta negative OH bond, and they both contain a delta negative, delta positive. I did that backwards. Negative, positive oxygen carbon bond, but the pentanol has all these additional non-polar bits sticking off, right? A bunch of carbon-carbons, a bunch of carbon-hydrogen bonds, right? So it's the same amount or origin of polarity that methanol has. It's just got a big non-polar arm stuck to it, right? So methanol should be more polar overall, right? It's got the same amount of polarity, but less non-polarity, maybe would be a way to phrase that. So it should have the lowest solubility in methanol.